Hello everyone, this is a short video for convolution operation. Convolution operation is the operation in filtering. For example, this is xn, the input signal, and this hn is the filter coefficients. Here the coefficients is 1, 1, 1. We have three coefficients here, as you can see. And here this is 2, 1, minus 1, 2. We use convolution in filtering. We have here two formula. They are equal, and we can use both of them. Here this is xk, h, and minus k. Here k is the variable, xk is the same as xn, but here h minus k. K is the variable, therefore h minus k is the reflection of h. We need a reflection of h here, or a mirror. Or we can use this formula. We change the places of h and x here. Here hk, in this form h keep the same, and x minus k is the reflection of x. Now let's do this convolution. We use the second formula here. We keep h as the same here. As you can see, hk is the same as hn. Okay. And we need a reflection form of xn, which is x minus k. X minus k is like this, the reflection of xn here. This is x minus k. In here, in this formula, as you can see, n is becomes 0, x minus k. Okay. This is n equals 0. If we multiply hk and x minus k, this is the multiplication of hk and x minus k. This is for n equals 0. We have y0. This is 1 and this is 2. The only the output here 2 times 1, which is 2. For the next output, we need to shift x to the right 1, and this is for n equals 1. And here this is x1 minus k. We shift the x to the right 1 step further. Okay, this is n equals 1 and the output y1. This is, we have here two samples here, 1 and 1 in h and 2 in x multiplied by 1. The output is 3. Yeah, we need one more step further. We shift x to the right 2 times here. This is x2 minus k. We have this, and let's multiply x2 minus k and h. Okay, here h. Here 3 samples can be multiplied. 2 times 1, 1 times 1, and minus times 1. This is 2. Okay. And one more shift to the right here, x3 minus k. Here. Yes. And this 3 sample can be multiplied by h. Here 1 times 1 minus 1 times 1 and 1 times 1. This one multiplied by 0 in h, okay. And we get a y3, which equals to 1. We can multiply more here if we shift x to the right. One more sample here. This is for n equals 4, and we have y4 here. This becomes here at 0 and 1 minus 1, and these two multiplied by 0 and 1 times 1 and minus 1 times 1, we have 0 at the output at n equals 4. Yes, we shifted to the right one more simple. Now only this one can be multiplied by h this time. The others will be multiplied by 0, and we have 1 here. Okay, if we shift to the right or left, we always multiply by 0, and we get 0 at the output, and this is enough for the convolution operation for us. Let's draw the output. This is y0, y1, y2, y3, y4, and y5. Okay, and this was the first method. This is a graphical method. We keep one the same and reflect the another one, and shift to the left and or right and multiply and get the results. And the second method for convolution is a bit more analytic. Okay, let's write the convolution here. As you can see, xn convolution hn. Okay, now in this method we have to write x and h function using delta function. Okay, as you can see here, xn equals 2 delta n, 1 delta n minus 1, minus 1 delta n minus 2, and delta n minus 3 here. And let's write the hn here. Hn is delta n plus delta n minus 1 plus delta n minus 2, because all coefficients are 1. Let's convolve these two. We write xn in the formula. As you can see here, this part is whole xn. Okay, this part all xn. Convolve by hn. Okay, and let's convolve hn by delta n. Here we have 4 delta functions in here in the parentheses. Delta n convolution hn is hn. Hn convolution delta n minus 1 is the hn minus 1, and delta n minus 2 convolution hn is hn minus 2, and delta n minus 3 convolution hn is hn minus 3. That's it. Then we have to write hn here, hn minus 1. We have hn here by delta functions here. Let's write hn. This is delta n plus delta n minus 1 plus delta n minus 2. We can write here by red. Okay, this is hn here, hn here. This is hn minus 1. Yeah, here we put n minus 1 for n here. Okay, that's all. This is n minus 1, this is n minus 2, this is n minus 3 as here. And here we have minus hn minus 2. Okay, we put n minus 2 for n here. Then we get hn minus 2. This part is hn minus 2, hn minus 2. and this part is hn minus 3. Hn minus 3. Okay. Okay, then we do some mathematical operations for same n's. Delta n, here we have 2 delta n, and there are no delta n here, we put here 2 delta n. And for example, 2 delta n minus 1 here, one more, 3 delta n minus 1, and we don't have any more. We put here 3 delta n minus 1. Let's look n minus 2, delta n minus 2, 2 times. Delta n minus 2, one more here, it is, we get 3. And here we have delta n minus 3 minus, we get 2 delta n minus 2. Let's see delta n minus 3's. Here, this is delta n minus 3. This is minus delta n minus 3. And this is 1 delta n minus 3. We have 1 delta n minus 3. And here there is only 1 delta n minus 5. Yes. And we write this. We get this. The output is this. As you can see here, this and the first and the second methods, we have the same outputs. Thank you.